Hello everyone, I am Associate Professor T.S. Dr. Jong Siat Ling from FKAE UTHM. Today I would like to share a topic on common discrete time signal in Chapter 1. The learning outcomes of this topic is, at the end of this topic, students will be able to identify, represent, and solve 5 common discrete time signals. The common discrete signals are unit impulse, unit step, ramp, rectangular, and triangular signals. The first signal is unit impulse. The symbol is delta n, and when n equal to 0, the amplitude is 1. When n not equal to 0, the amplitude is 0. So this can be illustrated in this figure where n equal to 0, amplitude is 1. Other than that, the amplitudes are 0. Next is the common discrete signals unit impulse properties. So first consider the product of the xn with the impulse delta n minus k. So this result in the xn multiplied with delta n minus k equal to xk multiplied with delta n minus k. So this means the impulse pick up the value of the signal at n equal to k. Okay, so this result in the result still is the impulse, but the amplitude strength is the xk. So this impulse acts like a sampler. It extracts the value of the xn exactly at the locations where the impulse occur. So because of these properties, so any discrete time signal can be written as the sum of the shifted impulse, where the xn equal to the summation k from minus infinity to infinity, xn delta n minus k. So this is so-called shifting properties. The second discrete signal is the unit step. So a unit step, the symbol is a un, where n start from n equal to 0 to infinity with the amplitude is 1. And when n less than 0, the value is 0. So this can be illustrated in this figure where n equal to 0 up to less than 0. Okay, from 0 to infinity, the amplitude is 1. So this is 1 un. If you have 2 un, means that the amplitude is 2. The third discrete signals is the ramp function. Ramp function, you can write the symbol as the Rn, where n equal to from 0 to infinity, you have the value n. N means that it starts from 0, and then 1, 2, 3, 4, 5 until infinity. Just like in this figure, okay? So n starting with 0, then you have the value, we must start with 0, we cannot start with 1. So that's why you must have the 0. It's just a ramp. Okay, ramp must start from 0. So 0, 1, 2, 3, 4, 5, 6 until infinity. So in case this is 2Rn, so means that every increment is 2. So you start from 0 again, 0, 2, 4, 6, 8, 10, like this. If you have 3Rn, that will be 0, 3, 6, 9, 12. Okay, do you get it? The next common discrete signal is the rectangular function, where we commonly write rectangular is RECT, rectangular, which take a short form. So rectangular n over 2 capital N. This equivalent to 1 when modulus n less than or equal to capital N. Other than that, you will get 0. Okay. And for example, if you have a rectangular n over 2 capital N for n equal to 3, so you have 3. Okay, you have the 3 here. This means you have 1, 2, 3. So right hand side you have 1, 2, 3. Left hand side also you have 1, 2, 3. So equal to 6 because the capital N equal to 3. 3 at the left and 3 at the right. So when 3 times 2, you got 6. So in total, we will have 6. So, and then if you look at here, so this is the shape of rectangular. You have the value of rectangular here. Other than that, you will get the value of 0. Okay, other than n equal to 3. So when n equal to 4, you have the value 1, 2, 3, 4 at the right and 1, 2, 3, 4 at the left. So that is from -4 to +4 for the rectangular signal. Okay, and if you write it, you will write rectangular n over 8. Do you get it? Lastly is the triangular function, where we can write the symbol is TRI, triangular. We'll take the short form also, and try n over capital N. So this will equivalent to when n modulus n less than capital N, you will have the value of 1 minus modulus n divided by capital N. Other than that, you will get 0. Okay, let's look at an example. If you have tried n over capital N, with the n here is 3, so this means it's n over 3. N over 3, the 3 here means the capital N here, the value means 3 at the right and 3 at the left. So, okay, so 3 value, so 1, 2, 3 value. Okay, 3 value at the right and 3 value at the left. So don't forget, this signal is triangular. It's a triangular. It must end at 0. So this, when you calculate for the 3 value here, you must take into the consideration. The 0 here, take into considerations. So you count 1, 2, 3, then 1, 2, 3. The origin value is not counted. Okay. So when combined together, the shape of this signal is a triangular signal. Okay, that's why it's a triangular function. Let's look at the example. Mathematically describe the signals below in at least 2 different ways. So there are 3 questions here, A, B, and C. So this is the first question. This is signal xn. So from this signal xn, you can write a numeric sequence. Okay, that represent this graph or this figure. So first of all, you can check where is the origin. The origin is at n equals 0, and then the value is 2. Okay, and then at -1, you have the value of 4, and at 1, you have the value of -1, and at 2, you have the value at 3. So you can just write down the sequence here. So 4, 2, 1, 3. Okay, you write down there 4, 2, -1, 3. Okay, 4, 2, -1, 3. 4, 2, -1, 3. And then where is the origin? Don't forget your origin here is the value of 2. So you will write down at the value of 2. This is the origin value. So you put the symbol like an arrow here. So this arrow here represents the origin. Okay. Then after that, you can also represent this figure in sum of shifted impulse. Okay. So xn equal to, the first value is 4. Okay, so the amplitude, 4 delta n plus 1. So this is n plus 1. N plus 1 is the location. Means that n plus 1 equal to 0, n equal to -1. So the location is at -1. And then what about the 2 here? 2 is at 0. So delta n only, because n equal to 0. And then when n equal to, location is 1, +1. So delta n minus 1. Okay, if you don't know, maybe you can say, oh, location 1 is n minus 1 equal to 0, n equal to 1. So this n here in the bracket n here is actually refer to the location of each value. And then the value of this location at n equal to 1 is -1. So you have -1. And then when n equal to 2, you have the value of 3. So here is a 3 delta n minus 2. Okay, n minus 2 is the location of 2, the n equal to 2. So when you combine together, so this is sum of the shifted impulse. Okay, so that's why you only can use the symbol of impulse only, or the signal of impulse only. So for delta n plus 1 plus 2, delta n minus 1 plus 3, delta n minus 2. Right, you get it? For question B, we also can express the signal yn in numeric sequence and also some of the shifted impulse. Okay, now let's look at the signal here. For signal yn, you have the value of 0, 0, 2, 4, 6, 6, 6. Okay, so for this numeric sequence, where should I start? Should I start at 2, 4, 6, 6, 6 or 0, 0, 2, 4, 6, 6, 6? Okay, the answer is 0, 0, 2, 4, 6, 6, 6. Do you know why? Okay, I mentioned it before, you must include the origin. If you not include the origin, you don't know this 2, 4, 6, 6, 6 is at what locations, at which n value. So you must add the origin. So although origin is a 0 value, maybe you think it's not important, but you are wrong. It's very important to include the origin value. Okay, so you have the value of 0, 0, 2, 4, 6, 6, 6. Okay, like this. So some of the shifted impulse, okay, for some of the shifted impulse, you don't need to include the two value, the empty value, means the 0 value. You only need to write the value, the shifted impulse with value. Okay, for example, you have the value of 2, 4, 6, 6, 6 only. So you can just start 2, okay, 2 is the amplitude, delta n minus 2. So this is at the location 2. And then 4, so amplitude is 4, delta n minus 3 at location n equal to 3. So you calculate 1, 2, 3. Okay, correct. So this 6 is the first 6 is location number 4, 5, 6. Okay, so you have the amplitude 6, location is 4, and then plus with 6 delta n minus 5. So this is location at number 5, this is location at number 6. So you add together, that will be sum of the shifted impulse. So make sure when you write for the sum of the shifted impulse, all the signal must the impulse function. Okay. Now I would like to express the signal yn into sum of the step and ramps. So this means that I want to the signal represented by ramp function and the unit step functions. So how to do that? Okay, so still remember our signal is 0, 0, 2, 4, 6, 6, 6. So first of all, we draw a table. Okay, when n equal to 1, 2, 3, 4, 5, 6, because you have the value start with 0 and then 2, 4, 6, 6, 6. So this is the first value is at n equal to 1. Okay, so this is a total sequence is you have 6 only, but we add the extra 3 column at the right. This is these 3 columns are the extra. So to make sure that at the end we obtain the value is 0, 0, 0. Okay. So okay, now we have the value of 0, 2, 4, 6, 6, 6, right? So we can put a ramp function, because ramp is start with 0, 2, 4, 6 at 10, 12, 14, 16. So we can write this one. We want this one. So we can write the signal is 2. So every increment is 2. So we put 2 ramp function n minus 1. This means that the n start with n equal to 1. Okay, because ramp, remember the ramp signal should be start with 0. So n is equal to 1. Okay, we have done these signals. After that, okay, what do we left? Okay, what we want first, 0, 2, 4, 6. This is what we want. And then this is, we need a 6 also, but this value is give you 8. So we need to minus 2 to get the 6. What about this value? Okay, we need the 6, but now you have 10. So 10 minus 4 equal to 6, right? So we need to minus 4. And then 12 we need to minus 6 to get 6 value. Okay, same to this one, to minus 8. So if you look at this, the trend here is 0, -2, -4, -6, -8. This is actually a ramp function. So now I start with the ramp function signal. So the signal is negative. So we put -2. So every increment is 2. And then when the n is start at where? N start at location equal to 4. Okay, this is the 4. So n minus 4. So we have -0, -2, -4, -6, -8, -10. Okay, now what we left? We try to sum up. Okay, 0, 2, 4, 6. So 8 minus 2, you get 6. 10 minus 4, you get 6. 12 minus 6, you get 6. 14 minus 8, you got 6. Okay, 16 minus 8, you get 6. Oh, maybe I can get what the front one that I want. So 0, 2, 4, 6, 6, 6. But notice that this is the extra 666. But supposedly you need to get 0, 0, 0, because this one is an extra column, and make sure this is you must get 0 so that not alter the original value or the value that you want. So this 666 is an extra. That's why I ask you to draw the extra 3 column at the right. Okay. All right, so how to remove this one? Okay, you will need to minus 6, minus 6, minus 6 to make sure this is okay. 6 minus 6, 0. 6 minus 6 also 0. 6 minus 6 also 0. So this is what the signal what you want. Okay, so you can return here. Okay, the signal here is negative. Amplitude is 6. So you get -6. Okay, amplitude 6. Okay, amplitude is 6. And then this is unit step function because same value. So unit step, then n minus 7 because the location start at n equal to 7. So you combine these three. Okay, so this sum of unit step function you can write as 2r n minus 1 minus 2r n minus 4 minus 6 unit step n minus 7 to represent the value of 0, 2, 4, 6, 6, 6. Okay, do you get it? Previous slide show you in a table form. Now I would like to share it with you in a graph or the figure form. Okay, so first value, you from the table form you get two RAM n minus 1. So 2 RAM n minus 1. So this means that the n equal to 1. You have the RAM function with every increment is 2. So 0, 2, 4, 6, 8, 10, and so on. So minus with 2 RAM n minus 4. Also a RAM function, but this is the amplitude is every increment is -2. So start with n equal to 4. Okay, from n equal to 4, so you have 2, minus 6, minus 8, minus 10, and so on. Next is minus 6 unit step n minus 7. So every the amplitude is minus 6, and then start with n equal to 7 here. So this total up, you sum up these three signals, that will become the value of yn equal to 0, 0, 2, 4, 6, 6, 6. This graph shows you a combination of three signals: unit step and unit ramp function. Now I would like to show you the last example. Okay, last signal is Hn with the value 24642. Okay, you can write the numeric sequence Hn like 24642, and then don't forget to put the arrow as a start of the origin. Then you can write the sum of the shifted impulse. Okay, represent the Hn with sum of the shifted impulse. You can put from based on this numeric sequence. Okay, so you have the amplitude 2 delta n plus 2. So this means that this is n equal to minus 2. So when n equal to minus 1, you can have the amplitude of 4, so 4 delta n plus 1. And then the amplitude 6 at origin, so you have 6 delta n. And then 4, n equal to positive 1, so you have 4 delta n minus 1. Okay, and then lastly is amplitude 2 at the location 2, so you have 2 delta n minus 2. So this is done for the signal hash n. And then next you can represent the signal with some of the ramps. Okay, so as I mentioned to you before, you must start with draw a table. Okay, so from here you notice that the signal is from -3 to +3. So the n value, okay, you can write the sequence from -3 to +3 and then add another 2 or 3 column for the extra to make sure that you get the last answer here is 0. Okay, to be sure that you don't alter the original signal. Okay, so the value that you have is 0, 2, 4, 6. So from here, you can estimate that this is the ramp functions. Okay, you can start with 0, 2, 4, 6, 8, 10, 12. Okay, 14, 16. So this one is a ramp, so you can, every increment is 2, so you can write 2 ramp. Okay, then start location is n equal to -3, so you write n plus 3. Okay, so this is the signal that you're 1, 0, 2, 4, 6. And then this is next. Okay, 2, 4, 6. The next answer that you want is 4. But how to get 4? From 8. So you must minus 4. So 8 minus 4, you get 4. Okay, this value you want to get 2. So 10 minus 8, you get 2. So from here, you'll notice that the trend here more or less like a ramp also, but with negative, okay, negative ramp. So you can put -4, okay, because every increment is 4. So -4 ramp function start at n equal to 0. So for this signal, you can write 0, -4, -8, -12, -16, -20. And then you sum up. Okay, 8 minus 4, you get 4, 10 minus 8, you get 2, 12 minus 12, you get 0, 14 minus 16, you get -2, 16 minus 20, you get -4. Okay, so you check again, it is the signal that you like. Okay, 0, 2, 4, 6, 4, 2. Okay, this is what you like, and 0. What about this one? -2, -4. This signal you don't want. You don't want this one. So you need to remove it or eliminate it. How to eliminate? Okay, 0, 2, 4. This is again is a ramp signal. This ramp signal is an increment every 2. Okay, every 2 increment is 2. So you got 0, 2, 4. So you can write 2 ramp n minus 3. Start at n equal to 3. Okay, so this is when you combine together, you get the ramp signal is 2Rn plus 3 minus 4Rn plus 2Rn minus 3. Okay, so this is the sum of the ramp. Also for this signal, you can represent in the triangular function where the hash n equal to 6. 6 is the maximum value. Okay, 6 is the maximum value, and then 3 at the right, 3 at the left, so it's n divided by 3. So these 3 represent the 3 point here. Okay, 3 point here. Alright, did you get it, class? Now is the exercise time. Please do the question below and submit to author platform. Thank you for watching. If you like my video, please hit the like button at the YouTube video. Thank you.